Find the equation of the tangent to the curve here at P, where x is 5, giving you an answer in this form here. The tangent meets the x-axis at Q. Find the coordinates of the midpoint of PQ. Find the equation of the line of symmetry of the curve, y equals 7 plus 6x minus x squared, and state the set of values of x for which 7 plus 6x minus x squared is an increasing function. So I've got all the information here. So find the tangent to this at P where x is 5. So here, let's just get dy dx then, the gradient function is equal to, constant differentiates to 0. X goes to 1 and there's 6 lots of, so 6 times 1 is 6. The 2 comes down to be with the minus, which equals, and then when we put 5 in, it's going to be 6 minus 2 times 5. 6 minus 10 is minus 4, and x equals 5. So there's the gradient function then. So where x is 5, and that's the gradient, so when x equals 5 then, it's a tangent to the function. So y equals, we can get the coordinate at that particular point, the y ordinate. So it's 7 plus 6 times the value 5, put it in here for x, minus the 5 squared, isn't it? So it's 7, 6 5s are 30, that's 30, take 25 is 5, plus 7 is 12. So we've got y minus 12 then, that's the y value, is equal to the gradient function, minus 4, times x minus the x value at that point P. So that's the equation of the line. So let's tidy it up then. Y. This minus 4x, when you expand the bracket, can move over to be with the y here. So it's 4x plus y, that's already there. Then we've got plus 20 here. Move that over to minus 20. We've already got minus 12. So that's minus 32. So there's our equation of the line in the form that was requested. Okay, so that's part 1. So this tangent meets the x-axis at Q. Find the coordinates of the midpoint of PQ. So part 2. So this line meets the x-axis at Q. So when it hits the x-axis, y is 0. So y equals 0 gives, so 4x, that will be 0, 4x, move the 32 over, and it equals 32, doesn't it? So x is equal to 32 over 4, move the 4 from time to divide, 32 over 4 is 8, so that's the x coordinate of Q. So this tangent meets the x-axis at Q. So y equals not x equals 8 is the coordinates at Q. So there's Q. So midpoint of PQ. So the P coordinate, let's write that down explicitly. It was when x was 5 and y had the value 12, wasn't it? So the midpoint here would be 5 plus 8 is 13. 13 divided by 2, halve it. And then 12 plus 0 is 12. Half that is 6. So there's our midpoint, halfway between P and Q. So find the equation of the line of symmetry of y. So the equation of the line of symmetry. So here's our quadratic then. Y equals 7 plus 6x minus x squared. If you were going to draw that, a little sketch, it's going to be a U-shaped curve, isn't it, like so. So we need the line of symmetry, so we better complete the square here, or we could find the roots. So let's just let that equal 0. So I'm going to find the roots. X squared minus 6x, I'm going to flip the sign. Minus 7 equals 0, because this should factorize quite easily here. X, 7 ones, minus and a plus, isn't it? Equals 0. So our roots are at 7 and minus 1. And it's a U-shaped curve because it's minus x squared. So it's going to come up and go like so, and then oops, come back down like so. So the equation of the line of symmetry will be somewhere in halfway between the roots, won't it? So this is x equals 7 minus 1 is 6, 6 divided by 2 is 3. So 3 is halfway between those two roots. So answer is x equals 3 line. There we go, there's the line of symmetry then, halfway between the curve. We could have completed the square and worked it out similarly. Okay, right, so that's the line of symmetry. State the set of values of x for which this is an increasing function. So dy dx then, when is that increasing? So basically let's write down what dy dx was from the previous question. 6 minus 2x, and basically we want to find out when is that increasing. So that implies then, move the 2x over here, read from right to left. 2x is less than 6, x is less than 3. So it's an increasing function, provided that x is less than 3. So you can see that it increases all the way up to halfway here.